Now that we have a few ideas of graph properties, things like degrees and connectedness and walks, we can define some special kinds of graphs, some specific graphs that we care about a lot. So here's one of them, a clique. So a k-clique, by definition, is a graph with k vertices in which every possible edge is present. So here's a few examples of k-cliques. So here's a k equals 2 clique. I have two vertices. Every possible edge exists. In this case, it's just one. Here's another one. I have three vertices, and then every possible edge exists. This time there are three available edges. Here's k equals 4. I have four vertices, and every possible edge exists. This time it's six edges. So k-cliques are the graphs that have the most possible edges for the number of nodes that they have. Here's another one, a tree. So trees are very important, especially in computer science. So a tree is a graph in which any node is reachable from any other node in exactly one way. Exactly one way. This is not a very formal definition. We'll do a more formal definition soon when we spend some more time focusing on trees. So how does this look? Well, let's consider nodes U and V here. So in this tree over here, so in this one, if I want to take a path from U to V, I only have one option. So I can go here and then I can go here. That's it. That's it. That's all I can do. So there's only one path from U to V, and so that's what I mean by reachable here. There's only one path from U to V. On the other hand, if I look at the same nodes U and V over here, this graph is not a tree because if I want to do a path from U to V, I can do the one I did in the other graph, or I can travel along this edge. There's actually two paths joining U to V. That's not okay. And so this graph on the left is a tree, but this one on the right is not. We'll learn some more formal descriptions of trees soon. So if you're feeling that this is a little bit vague, that's okay. We're going to get a lot more into detail shortly. One more special kind of graph that we can talk about is a planar graph. So a planar graph is a graph that can be drawn in 2D. So you can imagine drawing it with a pencil and paper without any edge crossings. Without any edge crossings. So what does it mean to draw without edge crossings? Here's an example of an edge crossing. So this is the same 4 clique as above. So this graph looks pretty bad because it has an edge crossing. But as it turns out, this graph is actually planar because if I just move around some edges, I can just take this diagonal, this one right here, and move it outside, and now I no longer have any edge crossings, even though I have a graph with all the same edges. And so this graph is indeed planar, even though it didn't look like it at first. On the other hand, it's a mathematical theorem that this graph, so this is the 5 clique, this graph unfortunately cannot be redrawn. It's possible to prove this, and so this graph is not an example of a planar graph. There's no way to redraw it that would make it work. So there's lots of special graphs. This is just a selection, and we'll encounter some more as we continue our exploration of graphs and graph theory.